Hello, how are you? It's been absolute ages since I was messing around with a Commodore VIC-20, trying to work out whether it would get man to the moon or not. And we never quite finished answering the question, I don't think, not fully, not properly. And if you remember, I was trying to build a AGC connected DSKY. So, what have I been doing? Where have I been for the last 8 months? And how have I been getting on? Well, that's what we're going to find out in this video. Stay tuned.
Working in verb 35, I think it is. We see a real display now.
Why buy just a video game from Atari or Intellivision? Invest in the wonder computer of the 1980s for under $300. The Commodore VIC-20. Unlike games, it has a real computer keyboard. With the Commodore VIC-20, the whole family can learn computing at home. Plays great games, too. Under $300, the wonder computer of the 1980s, the Commodore VIC-20.
That's a good demonstration of how Crew has the interface with the computer.
So here we are again, going to the moon with the VIC-20. And thank you for tuning in. And maybe you're one of my elite squad of 75 subscribers. And if you are, thank you so much. And if you're not, well, you know what to do. So where have I been? Let's answer that question. Well, you know, life sometimes takes a bit of a turn. And career-wise, that happened to me back in the last year. So I've been focusing on sorting out that situation, which is now done. Just about to start a new job. Very much excited about that, and that starts later this week. So I thought, you know what, I've got a few days off, let's try and get this VIC-20 to the moon video done, because I've been working on this. As you'll see, I've got lots of footage saved up to share with you, my fellow VIC-20 fans and space nerds. So first of all, let's take a look at the DSKY code that I've been working on. Now, as you'll possibly remember from the first episode of this series, I'm a complete assembly language newbie. So, and so much so in fact that when I was trying to get some help with getting this project off the ground and sharing some code snippets in the Denial forum, one of the great guys on there said to me, but I thought this was a little harsh, he said, I can't believe that a human could create such bad looking assembly language code. This must have been created by AI. I don't think he was joking, which was a little bit harsh, but fair comment, because, you know, I am a newbie and I've never been the best programmer in the world. Be the first to admit that, but, you know, I can get the job done. And I've been making progress, as I'll share. And if you recall, at the end of the last video, what I said was that we would look into the murky world of interrupts, because let me just remind you of what I'm trying to achieve. I'm not trying to create an emulator for the Apollo guidance computer on the VIC-20. I'm just trying to, at this point, create an emulator for the Apollo DSKY display and keyboard unit that you would have found in the lunar module when they were piloting and landing and ascending to and from the moon, and also in the command module, equally when they were piloting that. So, you know, I'm being a bit more realistic. I'm trying to keep the scope of what I'm doing sensible, but actually it's probably going to start to expand, as you'll see as we progress on this video. But also, as you'll recall from the previous episode, I've been doing quite a bit of research on the AGC itself. I mean, you've got to if you're going to attempt something like this. And of course, like any computer, the AGC itself had interrupts, just like any machine does when a piece of hardware needs to raise its hand and say, I need the CPU's attention for a moment. That's exactly what would happen on the AGC, just like it does on a VIC-20 or any other machine. So we can use that to our advantage, as they did when they were putting the AGC and its code together back in the 60s. And there are various different types of interrupts on the AGC, which again would be servicing the hardware requests of various things. not least of which would be the coupling data unit, for example, which was kind of like, I sort of think of it, rightly or wrongly, as kind of like a multiplexer box where you had various different pieces of hardware, like the DSKY, like the AGC itself, like the inertial measurement unit that was telling this, telling the instrumentation how the spacecraft was oriented, how fast it was going, etc., etc. All that good stuff that you need if you're flying any kind of aircraft, which again was only sort of recently been created by MIT. I think there was in Don Iles's book, Sunburst and Lumia, there's a section where he talks about the creation of that first kind of autopilot system where they flew a jet from one part of the US to another, completely automated using just those instruments that had been recently created. And of course, that's what drove the technological advancement that we saw around the Apollo program, and how still the space industry still drives technological advancement to this very day. So yeah, that's how it works. So you had this coupling data unit. Again, think of it like a kind of multiplexer, many inputs coming in, and that would be the box that really decided what signals were going to the AGC or input or output. So it's kind of like an input or output controller box, really, is a simple way to describe it. And if you look at Curious Mark's videos, again, huge inspiration to me. They actually have a coupling data unit in one of the episodes that they repair or take apart as they recreate basically their whole Apollo setup in that amazing fashion. So I'll put a link to the description to Mark's channel if you haven't seen it. It's absolutely fascinating. So if you're a Commodore nerd like me and also a space nerd, this is the video for you. But for your space nerdery around Apollo, go check out Curious Mark's channel. It's absolutely amazing what they do with that Apollo kit. So yeah, coming back to interrupts then. So I wanted to be able to simulate or emulate what a DSKY does. And really, it's only a kind of like a dumb terminal. That's all it is. I'll put a picture of one up on the screen now. Again, credit to Curious Mark for borrowing this screenshot. But it really is a dumb terminal, just a display and keyboard. That's where the name comes from. And if you think about it, that means there's not really a lot of intelligence and code running on the DSKY itself. And the trap that I started to fall into quite quickly was using my code to kind of emulate things that wouldn't have happened within the DSKY itself. They would have happened in the AGC and the data coming in and out through the coupling data unit, and not actually code running on the AGC itself. So I kind of had to sort of scale back what I was doing a little bit, and you'll see various iterations that I'll put on the screen now of the code running that did various things. But basically where I wanted to get to at the end of the first episode was to just be able to blink the lights. And I think it's verb 33 on the AGC that the astronauts would punch in to test the lights. And there is actually a video of one of the astronauts, I use it for the intro to this video, doing a verb 33 to test the lights on the DSKY. And that's all I wanted to really achieve in the initial round of coding. But I've moved a little bit further on from there, and I've used interrupts to basically monitor and poll bits of memory within the VIC-20's memory space and update the screen based on the contents of what's in that memory space. So putting it very simply, there's code that will just turn a light on and off based on whether it finds a 0 or a 1 in a bit of memory space in the VIC-20's memory. And that's very simple, and one of the things I've managed to achieve so far, like I say, as a newbie assembly programmer. So let's just have a quick look at the code, and then we'll jump into some of the other footage that we've got around. And actually, before we do that, what I'm trying to achieve here, I started to think, meant that I was going to need some more VIC-20s. So we needed to go on a bit of a road trip and scour Facebook Marketplace to see what we could find. So this is how that happened and how that turned out. But Louis, I'm not sure why you're going to Romford with Luke, but if it's got anything to do with 8-bit retro computers, could you do some content for me? I need 1, a hyperlapse of the journey, and 2, some of your excellent presenting skills. And you must slip in this phrase: we're going on a retro rescue road trip. Okay? Thanks. Love you. Bye. He's on his way now, by the way. Bye.
What's up, gamers? I'm here with my boy Luke, and together we're on a retro rescue road trip. We're off to pick up a little VIC-20 for Big Man Mark, and this is our journey, so we're going to take you on that. Yippee. See you in a bit. Hello guys, after that shoddy time-lapse drive, we've arrived and we've got the goods. That was a very successful retro rescue road trip. Peace out,
onto
homies.
KFC.
Onto the KFC, boys.
So obviously Luke and Louie were doing the job of Santa as Santa's little helpers, and on Christmas Day this happened.
No.
Oh, it's the friendly computer system.
No. Oh. He's lying.
Look at that.
He's lying. Not
all the way from a car park in Romford.
So there's a bit of distraction took place in the car park.
Yes. Serial number 384
Luke is
118. 118. How's he lost the power supply? I don't know.
He said his brother had it for a bit.
I bought one now anyway.
Oh, is that what went in that gap then?
Yeah. Real. Doesn't smell like fire.
No.
Yeah.
What did you say?
Beautiful. Thanks, guys. So after Christmas had come and gone, it was time to clean up what is now known as the Christmas Vic. So I wonder, do you find it therapeutic watching a 50-year-old man clean an old computer with what the Americans would call Windex, but we in the UK give the proper name of Windoline? That's Windowline. Yeah, giving it a good old scrub here just to clean off 40 years of grime from the case and getting into those really hard to reach grooves. Commodore bread bin cases have got lots of annoying grooves where grime and goodness knows what else does tend to collect. So you have to get in there and give them a good old scrub. So yeah, having done that, case was looking okay. Hadn't opened it up at this point to have a look inside or even tested it. We'll see me testing it shortly. But then I thought, what's going on in them keys? What's going to be inside there? So I turned it upside down, got the car hoover and gave it a good vacuum. Nice. So once all the degunking was done, it was time to unplug my normal Vic, my daily driver, and then plug in the new Christmas Vic and use the new DIN type power supply that I'd bought because my normal daily driver is a 2-prong. So yeah, there's me swapping them over and getting the video connection up and running. It booted, which was nice. So I thought, better run the diagnostics from the Penultimate Plus cartridge. Thank you, the Future Was 8-bit for this. Great utility, gives your Vic a good test to make sure that everything is running, at least on the surface, as it should be. So did that, then I thought, you know what, it's probably time to play with the SD card and run our Better Be Ready software that me and young Will wrote. There's a whole series of videos on that. Then I thought, cheese and onion, got to be done. Yep, looking good, joystick's working, everything's good. And then because Snake games are the best games, it was time to have a little go of Nibbler. And I do quite well here, I think. Get through quite a few levels, which for me, it's not bad. Doesn't look good sped up. Quite enjoying that. So thanks so much to Louis and Luke for going on that road trip for me last December now, and actually securing that second VIC-20. And as we sort of go through the code, I'll try and explain where the second one's going to come in and what I'm going to try and achieve next and how far I've got with that. Not fully there yet, but I've made some progress and it's going to take a while. So let's jump back into this code then. So in a nutshell, as I say, what I've really got is a dumb box, and I wanted to trap the interrupts on the VIC-20, like I say, for me to be able to poll areas of memory and turn the lights on and off basically based on what I find in those areas of memory. So I've got variables for every lamp on the DSKY set up there in a memory space defined, and I can set and reset those bits as would happen in a slightly different way on the AGC in real life. But what I'm doing with my zeros and ones in those memory spaces, I guess, is kind of emulating the relays that would be turned on and off, that would turn the noctilucent displays on and off, the segments on those beautiful displays on the DSKY on and off. So we're kind of emulating what's going on there with the kind of mechanical switches turned on from digital signals to make that happen, make those lights come on and off as required. On this is, as I say, what is essentially a dumb terminal. So I've got some code here that will set up a new interrupt handler and turn it off as we tidy up the code when it terminates at the end. So you can see that there. In fact, let me change my font size. Can I do that in here so you guys can see? There you go. There we go. Hopefully that's made things a little bigger. Let's get the Project Explorer out of the way. There we are. Okay, that's much better. We should be able to see what we're doing now properly. Okay, so like I say, now you can read the code. There's code here to set and unset a new interrupt handler. So we do that, do our little bit of processing, and then we return control back to the VIC-20 proper for it to carry on what it would normally do in terms of interrupt handling. So in our IRQ handling routine, all we're really doing is saving the values onto the stack of the registers, and then checking to see if the display is dirty, it needs to be updated, yes or no, based again on a 0 or a 1 in memory. And then doing a little bit of checking to make sure we only do that if the display raster line draw is on line 20 for the VIC-20. We wait a little while if not, and then we proceed to run the blink lights routine, which does the most of the processing. Once that happened, we just take the values of the registers back off the stack and put them back where they were, and then resume processing as normal. All sounds very simple, but for a newbie programmer like me, obviously it wasn't. But there we are. Here's my code that resets the lights. Again, just stepping through each of my variables, checking to see if it's a 0 or a 1, and then basically setting that value back to what it should be, and then setting the display dirty flag so that the next time the interrupt runs, we know we need to update the screen. And then here's the main guts of it, if you will. Blink lights. Again, very simple. Just writing to the screen and turning some attributes on or off, colour, reverse video on certain areas of the screen, and you'll see it as the code runs as to how it looks. So yeah, quite simple stuff really. Again, probably not the most elegant code and way of doing it, but I'm learning, and I'm learning all the time. So the other thing that I've needed to do is also to start to check for key presses. So again, that's something I hadn't done. So you can press Q to quit, but at one point I also was, and again this is where slight scope creep came in. At one point you could press V and then enter a verb, or N and enter a noun, and I had that code running, but I've since taken that out because if you think about it, it shouldn't be there. I'm just trying to emulate a DSKY. What I'm going to need to do way down the line is to actually have something which emulates the AGC itself. Now we're getting way ahead of ourselves there, and I'm never going to try and create a whole AGC emulator on a VIC-20 because, for one thing, the real AGC had 35k words of memory. It used 15-bit words. A VIC-20 at its highest memory has only got 35k. So I'd need 2 VIC-20s to basically emulate it, or some kind of crazy RAM expansion that doesn't exist. So and again, that's where we come back to: could the VIC-20 itself, unmodified, fly men to the moon? And I still think the answer is probably yes, but we'd need to be really clever, with our memory mapping and control, and maybe introduce some extra banking with a special cartridge or something. I don't know. But again, we're getting ahead of ourselves there, and that's something we don't need to worry about if we're just trying to emulate a DSKY. So a little bit of key processing here. So the only key which really is responding at the minute is Q to quit the program, which is fine. But what does happen is that when the keys are pressed, it will check to make sure that we've only pressed one of the valid keys that the DSKY would accept, because obviously it only had a limited keyboard input of certain keys that could be pressed and numeric digits that could be pressed. So I'm checking to make sure, using the PETSKY values of all those as the keyboard input goes on, to make sure they're valid. And then all I'm doing is sending the valid data that comes in from the person, the astronaut or me, pressing the key. All I'm doing is just pushing that into a memory location to be processed later, because that's the job of the sort of, coupling data unit, to take that data and route it through to the AGC from what is the dumb terminal of the DSKY. So again, some code in here for processing a verb and processing a noun, which again is just left over from what I did before, which I've kind of disabled at the moment. But all of the noctilucent display elements are here and handled, so I can turn them all on and off now. But what I haven't got is the code coming in to set the bits to make things happen. And that's where we come on to the next thing. And let me just share with you another bit of footage of me working on a little bit of hardware. And as you can see, what I'm doing here is creating some cables to basically connect two VIC-20s together using the Userport connection that the VIC-20 supports. So I've bought some Userport connectors from the Future Was 8-bit, thanks Rod. And what I'm doing is using automotive spade terminals across some of the pins, sometimes single, sometimes double pins, to create connectors for either end, where I can basically connect onto the Userport of what I have now, two VIC-20s. And in fact, I actually have three VIC-20s now, because I managed to pick up not only a VIC-20 but also two Atari 800 XLs as well at the same time. There was someone on Facebook Marketplace selling those quite cheaply earlier in the year, and I thought, you know what, let's grab at least a VIC-20, and I said, I'll take the Ataris as well, and that will be a later project to get those going. I've shared one of them with a friend, he's taken one away, and I hope he enjoys it. So I've now got three VIC-20s, which is good, because ultimately, if you think about it, if we're really replicating some of the AGC and Apollo hardware with a VIC-20, we're also going to need to replicate, as I say, a coupling data unit and an AGC itself, ultimately an inertial measurement unit, the optical platform. If you're thinking about this, and this is the beauty of the design that the guys at MIT did way back when, is that all of the Apollo kit was modular. It was literally in, nice sort of, they look like brushed aluminium boxes. I'm sure they're not that, but they everything is nicely screwed down and screwed together, as of course it would need to be for a spacecraft. But it's modular and it all connects together. Years before USB was invented, people were thinking that way on how to make, kind of universal connections between computing devices. At a time where integrated circuits were only just being invented because of the Apollo program. So fascinating stuff. So yeah, that's kind of a bit of a walkthrough of the code. Let me just give it a quick run so you can see what's happening. It's a bit unimpressive, to be fair, because like I say, at this point in time, not a lot should be happening, because I've got no other peripherals connected to my DSKY to send data in and out of it. But I have written the code so that when we get to that point, we will be able to see things happening. So there we go. We're loading up, and there we go. So you'll see, since the last episode where everything was green, what I've done is you know, looking at Curious Mark's video on a kind of replica DSKY that those guys had in Mark's lab, took the, you know, screenshot of that as my guide for redesigning the screen a little. So hopefully I've made the screen display itself here look a little bit more like a real DSKY. And when you first switch the thing on, as you'll see, some of the lights, the lamps in these NLRs do display straight away. And again, what's new is this section. I've just, you know, made this look a little bit more realistic, and I've added and zeroed down the 3 banks of registers that the astronauts would use as you know, instruments, and would also use as input when they're keying in on the keypad of the DSKY itself. And over on this side, obviously what we've got is just indicator lamps that we went through in the first episode, so check that out if you're not sure what all these things do. We did go through them in a bit of detail in the first episode. So yeah, like I say, it's not the most exciting thing in the world right now, but I think actually I should be able to make the error light come on. Oh no, I didn't. Made an error. But yeah, so that's the code as we have it today. So yeah, let's go back now and see what else has been going on since I spoke to you all last. So having cleaned up the VIC that I got with those 2 Ataris, I found that it didn't seem to boot, but it was just a black screen. So if you can spot anything wrong with this video circuitry, do let me know in the comments. I can see it coming out of reset, I can see the voltage is changing on the pins, so it is running and executing code, but all I'm getting is this unsynced video. So if you've seen that symptom before, do let me know in the comments what you think it could be. I'm going to have to rebuild the video circuit, I think. Time for some unboxing now. Me ineffectually unboxing something. Thanks to Andy and the Future Was 8-Bit for releasing this new title, Emu's Massive Hunt. Really looking forward to playing this one, and getting it out of the box was a challenge. So there we are. That's everybody up to date with where I got to with my sending the VIC-20 to the moon project. So what's next? Well, basically, I need to test out those cables. I must get a new multimeter. That's one of the things. I had to borrow my dad's. You know, I didn't want to keep hold of it for like months at the end, so I gave it back to him. But I need to buy one so I can test continuity. I can also continue to repair that VIC-20 that you've seen during this episode that isn't quite working with the video sync issues. So yeah, finish off the cabling and then basically try and connect 2 VIC-20s together and write a little test program so I can send bits back and forward over the Userport. So I think that's going to be my next milestones for the project. So hopefully you've enjoyed this one. Like I said at the beginning, if you're not one of my 75 elite subscribers, then do click the bell and also click subscribe so that you know, when I do eventually get around to making a new video, then you can catch up with it. I know this is very niche. How many Commodore space nerds are there? I'd love to know. Let me know in the comments. Is it just me? Is it just me? Who knows? Anyway, thanks for taking the time to watch this. It's been great to be back and to be able to do another one of these after the crazy year I've had so far. And let's hope the rest of 2024, for not just me, but everybody out there watching, is amazing. It's a beautiful sunny day today. It's the hottest day of the year, but I'm managing to stay cool, and I hope you do too. Take care, and I'll see you again soon. Bye-bye.